All right, this video we're going to talk about some inscribed angles and their measures. If you're one of my students, this is going to be section 9.4 in your note packet, so you can follow along in there. We're going to take all of those notes for section 9.4. First one is inscribed an angle. This is going to be an angle whose vertex is on a circle, or you might want to say on the curve of the circle. That's going to be right there. And also whose sides contain the chords of the circle. In other words, if I have this ray coming out for that part of the angle and this ray here, that contains the two chords, you might say here and here. All right, so that's what it's talking about, is we've got the vertex on the circle, and then the two chords that break it up. An intercepted arc is going to be the arc that lies in the interior of the inscribed angle and has endpoints on the circle. In other words, if I have this angle, right, the intercepted arc is going to be the part of the circle that's in the middle of that angle, like this, the blue part I just highlighted. So if you need to pause the screen there and write those down, you can. Otherwise, you have a few problems we're going to do with this. It says the intercepted arc of BED is what? And if I follow this around, say BED, that's going to go down this line to E, and then over here to D, just like this. And if you think about the intercepted arc of that, well, what is the arc in the middle? Well, let me switch colors. That's going to be arc BD. And so if I were to say this is arc BD, remember arcs get a little arc above it, and we can use that information to help us find that answer. All right, let's try again with angle DCE. Okay, DCE. Stylus is going crazy here. DCE, there we go. DCE is going to be that one. And with that, its intercepted arc is going to be in between the D and the E. So right here, this arc and DE. Now you might notice a pattern, and that is that the first letter and the last letter are going to be the parts of the arc that we write down. And so for the example, that next one, where it says angle AED, I don't even have to graph it on our picture over here. I can just say AD is going to be the arc that's intercepted by angle AED. You can use the first letter and the last letter. And then the last one here, AEB, that's going to be AB. The arc AB, that's going to be the intercepted arc of those two. So you can plot those. In fact, let's just do one really quick. Let's do that last one. AEB, AEB coming up here. Well, of course, in between that, it's going to be the A and the B, and that's what we had. All right. Another theorem that you might write down is the inscribed angle theorem. This says that the measure of an inscribed angle is half the measure of its intercepted arc. This is probably going to be the one you use the most in this section, so make sure you write this down. The measure of an inscribed angle is half the measure of its intercepted arc. So if I were to take a random number here and say this inscribed angle, maybe is 40 degrees. Well, if that's half of the intercepted arc, what is half of 40? 80. Or I'm sorry, what is half of what is 40, I should say. Half of 80 is 40. And so the arc would be 80 degrees, whereas the angle would be 40 degrees. And the way that I like to remember this is the angle, this gets really small down in there, whereas this side is a little bit bigger. And so, of course, it has to be double as you work it that way. Okay, we can go through and try some examples with this. If you need to write that down, you can pause the video. Example 1, though, here I have a 90-degree angle, and so therefore its intercepted arc, which would be here, would be double. And what's double 90? 180 is. So again, the arc is double, the angle is half. If I have 115, well, what's going to be double that for the intercepted arc? Well, 100 double is 200, and then 15 doubled is 30, so it's going to be 230 degrees. And then I can also do it backwards. This time they give me the arc, and so I need half to get back down here to the angle. What's half of 160? That's going to be 80 degrees, like this. So you're going to have a lot of problems on your assignment later today that do problems just like this. Okay, now with that, there's a couple of things that come into play. First off, if two inscribed angles of a circle intercept the same arc, then the angles are congruent. In other words, this says angle ADB right here, well, that intercepts what arc? It intercepts arc AB. Whereas, if I look at the other one, I'll switch colors, ACB, this intercepts also arc AB. So because they intercept the same arc, you can put any number you want here on the outside. Maybe we'll say it is, oh, if I get my stylus to work, this is, let's go 80, call it 80 degrees. And therefore, each of these on the inside would be the same. They'd be half, which would be 40. Because it's the same arc, this one has to be 40, that one has to be 40. It doesn't really matter what the number is, but they're saying that angle D and angle C are congruent. In fact, if I erase all this, that is why it has these lines or these loops in here to show those two are congruent, because they cut through the same intercepted arc. With that, if I look at the next theorem, this says an inscribed angle that intercepts a semicircle is a right angle. And the reason for that is, remember how many degrees are in a semicircle. Semicircle ADC here, that has to be half of a circle, which is 180 degrees, since a whole circle is 360. And if I think of this angle coming down, which cuts like this, well, it has to be half of 180, which of course is our 90. That has to be true if that cuts, if it intercepts a semicircle. It's going to intercept it with a right angle. All right, example 4 says x equals y equals z. What's the measure of x, y, and z? Well, again, all of these, you can see they color-coded them for you. They all intercept the same arc, arc AB, which is 70. And so whether it's x, y, or z right here, those are going to be half. So if I take 70 divided by 2, half of 70 is 35 degrees. I don't know what's with my stylus today. I apologize. 35 degrees. Okay. The same math is almost true on number 5. This says, what's the measure of x and y? Well, again, they both cut through the same intercepted arc here. And that means that those are going to be congruent. So x and 35 are going to be the same. In other words, x equals 35 degrees. And that's going to be half of what y is. Well, what's 35 times 2? 70. Again, it's the same math as this problem. All right. Okay, let's try some different ones with polygons now. And when we talk about polygons, we need to know that an inscribed polygon, when I say that, what is an inscribed polygon? This means that all the vertices, all the corners of our angles of that polygon lie on the circle. Okay, just like that. So I could have different types of inscribed polygons, maybe an inscribed triangle. You know what, I think it's easier if I draw the circle first. Maybe. Maybe up here it'll let me do it better. My goodness, no, it doesn't. I need a new stylus. All right, so if I did an inscribed triangle, you can have all different shapes of triangles. Why does it stop halfway through? And maybe I have an equilateral versus an acute, okay? So something like that. Those would all be inscribed as well. So let's use that to help us with some of these different ones. This one says that if I have a right triangle inscribed inside of a circle, the right triangle inscribed circle, then the hypotenuse is the diameter of the circle. The only way that can be true, the only way to have a right triangle inside of a circle like this is if it cuts through at the diameter. All right, so here, because this is 90 degrees, again, if I think about where, if I extend those, where those angles go, it has to be double 90 where that intercepted arc is. And of course, if I double 90, I get 180 degrees. And so it has to be at a semicircle, which means this has to be a diameter. So I know I'm drawing a lot of stuff on here, but that has to be true because 90 degrees is the biggest angle you can get inside if you have an inscribed triangle in a circle. Quadrilaterals inscribed in a circle theorem. This is also interesting. It says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Remember, supplementary means it equals 180 degrees when you add them up. And so therefore, these opposites ones here, B and D, those are going to add to be 180, as well as C plus A those are going to also add to be 180 degrees. So let's use that to our advantage as we try a few of these next few problems. In example 6, this one says that we need to find x and y. And you'll notice here that they give you a dot like this. That's usually talking about the center. And because it's the center, that means that this length right here is a diameter. And if that's a diameter, right away I can say that y is how many degrees? Well, based off that last theorem, it's going to be 90 degrees. Okay? And if that's true, then I also know that if this is now 90, to find x, I can say that 90 plus 2x plus 34, those all inside of a triangle, so that has to add up to be 180 degrees. Okay, if I do a little bit of math here, 90 plus 34 is 124, plus 2x equals 180. And if I subtract 124, that's going to give me 2x equals 66. If I divide by 2, I get, I'm sorry, that's 56. 56. If I divide by 2, then I get x equals, what is that, 28? 56, double check on a calculator. You might want to have a calculator handy as well. Minus 124. And yeah, 56 divided by 2 is 28. Okay, there we go. So this next one, example 7, here we have another diameter. Again, this is going to be a radius out to the side here. And this one's really tricky because we don't know very much of anything at all. All we know is that AB is a diameter. And if that's true, then we also know if this is a radius, I have a few other radii here. This is going to be 5 and this is going to be 5 because the fact that that's a diameter. And how does that help me? Well, let's see here. It wants us to find angle B first. And so in this triangle, I can do 180 minus 90 minus 58. 180 minus 90 minus 58. And that's going to give me 32 degrees left. So angle B is 32 degrees. And then AB, because those are radii, 5 plus 5, of course, is 10. Okay, just like that. All right, a couple more, and then we'll be done. This one says the polygons below are inscribed in the given circles. We need to find x and y. And with this, because it's an x and a y, you can't make the same equation using different letters. So I'm going to use the x first, and with the x, I have to use the opposite one. Remember that the opposite angles in an inscribed quadrilateral in a circle are going to be supplementary. So I can just do 180 minus 104, and that's going to leave me with 76. So 76 degrees is what x is there. And then get rid of that. Then I can do it the other way and say 180 minus 115 for the y. And 180 minus 115 is going to be 65 degrees for y. Okay? All right, on the other one, we have the same math again, 115, and this time it's an x though, so x is going to be 65. However, the other way, I'll switch colors, these also have to add up to be 180, and so because we're both y, I'm actually going to set up an equation, say 3y plus 6y, 6y equals 180, and 3 plus 6 is 9y. And how would I solve this? Well, I'm going to divide by 9 and get y equals 20. Okay. Now notice that's not going to be, in fact, I shouldn't put, I guess for x it's fine because it's only x, so I can say 65 degrees. For the y though, that's not necessarily 20 degrees, it's just saying that the variable itself is 20. So be careful with that. Okay, and I think I have one more maybe. Yeah, this one says the polygon below is inscribed in the circle, find x and y. One more time. And this one, You know what, I'm going to let you guys skip this one if you want. Yeah, you could do it if you set up a system of equations, but because the opposites, here's something to look for, because the opposites have different letters, we don't necessarily know how to do that. Just kind of with regular equations, you have to set up a system. It is possible. You got to really think back to algebra class though, okay? So be careful with that. All right, you're going to have an assignment if you're one of my students, the 9.4 assignment, so make sure you get that done, and that'll be due next time in class.